This morning we talk a lot about the Moore's law, and last week I was in Taiwan for another keynote speech, and at that time I got a feedback from a lot of people. Right now, Moore's law is even accelerating right now, like 4x faster, but it will be even faster with the adoption of more AI and the robotic systems we talked this morning. So the AI system computation requirement is actually the requirement is not slowing down. It is more accelerated. And another aspect to see this market, high-performance computing semiconductors are driven by system users, like hyperscalers, hyper chip users. So conventionally, the chip design is done by the chip makers, but right now, chip design is driven by hyperscalers, like the logos over there. So, and also, but in contrary to the hyperscalers, company NVIDIA and Samsung, they are driving, especially for NVIDIA, they are very fab technology focus driven, and then designing into the systems. But as Mohamed just mentioned, multi-chip integration is critical for 3D heterogeneous integrations. So it is inter-chip integrations and inter-substrate integrations, and should solve the electromagnetic coupling because of complicated systems and efficient power management design. But the problem is actually two topics is a little bit contradictory. The too many approaches versus one or two company drives everything. So this is a current problem statement. For 3D HDI, a new paradigm shift is required. So right now, the left side, that one is a typical 2.5D solutions. But the requirement by 2030 is less than 10 micrometer bump pitch and per square millimeter, more than 10,000 transistors. So it's 1.2 trillion transistor per processors. So semiconductor package concept should be changed. Many people talk about the packaging is a space transformer, but the concept changed. Actually, I spoke it for the first time, space transporter. So packaging concept is different. And optimal elevators for signal efficiency and ultra-wide bandwidth. That's why SK Hynix making so much money these days because for HBM memories, and the layer transfer for photonic devices. So packaging architecture innovations are required to manufacture and ensure reliability. So that's why so many companies are working on that. But again, as I told you previously, this topic cannot be solved by one or two companies. So this is the biggest issue. So, and also supply chain management. Conventionally, the IDM did almost everything from system design and then, except for the tools and materials, they did everything. But it has been fragmented deeply these days. So multiple players, especially multiple regions, multiple players, and the logistic difficulties and uncertainties and the complexity in production and the supply security and resilience. That's why there is a geopolitical issues for semiconductors. All right, this is a problem statement. It's too complicated. If you're talking about supply chain, the 2.5D package solution is already complicated. But if you're thinking about supply chain, too many companies are involved to serve this solutions. So, but challenges, in other words, is opportunities. So if a company or some company can solve these challenges, the reward is ultimate first mover, and first mover take everything these days, and unparalleled expandability. So it is a unified collaborations are required in material processes, structures, and design optimizations. And Absolix, our company, is focusing on packaging substrate. And we are specialized for glass. Why? The glass has fundamentally material is pretty similar to silicon, that of silicon, comparing to plastic substrate. And the biggest benefit is tunable CTE value. So this is, I modified this one deeply. So the multiple materials, glass, monosilicon, polysilicon, plastic, and ceramic, and the glass has a lot of greens. I won't go detail for this. And there are multiple approaches: small scale glass, wafer scale, and the big panel. So big panel is the most difficult, but like half a meter by half a meter panel, if we solve that issue, it will provide cost-wise and also the integration, multi-chip integration-wise will be a lot better. And the people talking about glass here and there, but the left side, 2.5D solution, current conventional solution, there are three approaches in the market. The blue is glass. Replacing interposer with glass is glass interposer. And replacing flip chip BJ, plastic BJ, into glass core is a glass substrate. And a company like us is fully integrated substrate. All the components, except for silicon, GPU and HBM memories, embedding inside of the glass. So this is a chip on fully integrated substrate glass. Last 10 years, as President Cabrera mentioned this morning, this technology has been incubated in Georgia Tech, and I proposed this business to SK Group, and then 2021, we were bold enough, brave enough to set up this factory in North America, in USA, and also the setting up. And the last year, this year, CES show, we demonstrate first full panel glass substrate in public. So it's a lab to fab, took 10 years. And this is the X-ray photo. It consists of 498 actual capacitor, huge capacitor inside of the glass core, and the multiple layers. And it's the most fine patterns has been implemented on glass panel. And this is one unit glass. So everything, the passive component is embedded inside of glass and directly pumping the power to GPU and HBM memories. What it means, because conventionally 3 centimeter electron pathway shrink into 300 micrometer. It consumes a lot less power, and it creates a lot less heat, and that's why it delivers unparalleled performance. So this is the role we are playing in this market. So this is my last slide. So conventional supply chain at that time, the past value chain used to be chip design and wafer fab and the substrate design, and then just produce substrate. But right now, because of chiplet and 3D HDI, heterogeneous integration. This process has been changed, like a system in parallel with the system design. Chiplet design should be in parallel, and the wafer and the chiplet fab, during that time, the chiplet package design should be a process in parallel. And 3D HEI, package substrate. Package substrate role is quite critical. So this is, in my view, this is the opportunity even for Europe. So advanced packaging integration for scalability. This is a critical gap for this industry. Early prototyping is critical because time to market, especially for high-speed communications and high-performance computing, this is money. And technology scale down plus integration scale up is required. And the wafer fab front-end know-how should be deployed to back-end. So this is my end of my slide. And this is the opportunity. It's my first time to be here, as I mentioned, in Spain. And this is opportunity, Spain, as well as whole Europe, advanced packaging. So there are different applications by countries. Why I set up the company, glass substrate company, manufacturing company in Georgia, USA, because almost all the users of AI drivers, they are in USA. So if you're trying to benchmark very similar business model which America did, the possibility of success may be less, in my view. But in Europe or Spain, you have your own demand and you have your own domestic privileges and advantages. Utilize that requirement and needs and focus on multiple packaging options and create your own ecosystem locally here by adopting some new technology outside for advanced packaging. I think this will, in my view, this will be a good solution for Europe semiconductor market.